Let's look at another example. Continuing lecture 10 here. This is our 5th page of notes so far. So, just so you kind of see what I'm drawing here, similar setup, different numbers, different type of setup. We've got a cable here from this endpoint B to C. We've got a square collar. So it's a peg with it's a square-shaped peg and a collar fitting closely over that. I should 3D print something like that so we can kind of see that for this example. Anyway, I'll draw this with you guys so you've got it in your notes. I'm going to draw a square-shaped peg here, kind of at the, this is going to be basically, we'll call this point A, where the square-shaped peg meets this collar going around it. So this hugs it basically, and you got this outer collar going around this thing. And then we're going to say that, what are we going to call this? We're basically going to call, I'm going to rotate this a bit, so to speak, and we're going to call this kind of the X direction. We're going to say this comes out a long, crazy distance, 12 foot in this. We're going to, if we say this is X, that means this is Y, and straight up and down is always Z. So this is going to come out 12 foot in this way, 4 foot in this other direction. So probably not anything realistic, just a standard textbook problem that doesn't really, maybe it relates to something somebody's seen somewhere, I don't know. So, and then you're going to have a cable out here that's going to attach to a wall, so to speak. So we'll call this point A, where this square collar is. Point B be the end of this out here, and you got this cable that kind of attaches, hangs over the end of this, wrapped around, and then up to this point C. Up here. Point C. And you can draw the square peg a little further down. Right, and so basically what this means is what we want to do, let's just say what we're looking for. Find the reactions at A and tension in cable BC. Now we need to also go ahead and load this up with a force. There's a force right here at this elbow, straight down in the Z direction, minus 45 in the K direction, pounds. I'm going to close my door. Be right back. Okay. So 45 pounds in the K direction. Again, I would call this the X direction between, basically on the long arm of this rod here. And this is a 12-foot crazy length, 12-foot span in that direction along the arm. And then from here to here, where that elbow occurs out to where the cable is attached, 4 feet. And then point C is out here, the distance along in this, basically this, what we're going to call the Y direction. It's going to be 8 foot. I'm not drawing this to scale very well at all. And then vertical here is going to be 6 foot. So again, not well drawn to scale at all. So what I would suggest is calling the long arm of this the X direction, the positive X direction. This is positive Y going out this way, and positive Z I'm going straight up. And that's what I'm going to do. You're welcome to call kind of standard this being positive x, and this would be putting this out in the positive y, and you've got stuff back over here in the negative x. That's okay. I'm going to just kind of keep everything positive. Everything, if I call this x and this y, that keeps everything kind of in the positive xy plane out here. There's an advantage to that if you don't like negative signs like me, but whatever works for you. X and y is whatever you want to call them, as long as to go from x to y, your hand closes around the positive z-axis. So calling this x and this positive y, that's okay. Or again, like normal, I would call positive x out here if this is positive y. As long as it follows right-hand rule, you can assign your x, y in any direction you like. All right, so we want to find the reactions at point A, our square call here, and find the tension in cable BC. Okay, so the square collar is kind of a weird reaction. You won't see it very often, but it's a neat little thing. And there's a type of bearing that's similar to it. But let's draw a free body diagram. What am I looking for? I'm looking for reactions. Those are forces and moments. What's a good way to find unknown forces and moments? A free body diagram. And so I'm just going to draw a simple wireframe of this thing, this elbow, and I've got this 45 pounds. When I draw a free body diagram, I like to draw everything resolved into its x, y components. So again, let's keep definition of these here. This is x, this is y, and this is z. So I've got 45 pounds out here in the negative z direction at the bent elbow of this thing. That's this 45 pounds here, applied down there. 45 pounds, negative z direction. I also have tension's going to be applied here. I need to resolve that, which means I need to do a position vector. But let's look at point A here. So again, it's this square collar. So this thing, how can it move and how can it rotate? Well, it can move up and down, right? It can move up and down. But if I grab on this thing and try to pull it in the positive x direction or push it in the negative x direction, there's something keeping it there. There's a reaction force, AX, keeping me from pushing or pulling this thing. And if I try to push or pull it back and forth in the y direction, it's not going to let me do that either. So I'm going to draw a reaction force in the positive y. Now you could draw it in the negative y. If you look at this and say, Steve, that's a negative x and negative y reaction. You want to draw it that way, that's fine. I'm going to draw it this way, and when I solve for it, I'm going to get, if I get a negative value, that just tells me, well, I guessed one way and I guessed wrong. So this thing can hold force in either direction, in the x and in the y. It can hold positive or negative force. So I'm just going to draw it positive, solve for it, and if I get a negative value, that just tells me, well, I just drew it initially wrong. And I'll do the same thing with the moments, right? So if you look at this thing, if I grab it out here and I try to twist it about the x-axis, this x-axis, if I try to twist it, it doesn't let me twist it. So I'm going to have a reaction moment in the x direction. Same thing if I try to, this being my y-axis, if I try to rotate this thing about, this y-axis, if I try to get it to rotate about this y-axis, it doesn't want to do that. So I'm going to have this, oh, no, positive y direction is this way. Moment reaction in the y direction. And thumb out there, this is trying to close with my thumb in the positive. That means if I draw a positive reaction moment, that's the direction it goes. And the same thing in the z direction. If I grab it out here and I try to twist it around the z-axis, this square shape is going to prevent it from actually rotating in the z-axis. So I am going to have a reaction moment in the z-axis there at point A. So it's allowed to move in the z direction up and down, but that's it. I can slide up and down that square peg, but it can't rotate about the square peg in any direction. It can't move in the x or y direction. And then I've got a force, a tension out here. All right, so, but I've got to describe that position vector from C to B there. And we're going to describe a position vector from C to B there. Well, so that position vector from C to B, we've done that several times. I'm going to assume that you can do that. Pause it if you want to go ahead and do that and see if you get what I get. Go ahead and pause it. All right, how'd you do? I've got, going from B to C, I've got minus 12 in the I direction, plus 4 in the J direction, plus 6 in the K direction. Those are all feet. And then the magnitude of that vector, I've got 14 feet. So that means the unit vector, and I'm going to reduce these fractions because I've got 12 over 14, that's 6 over 7. So I've got minus 6/7 I. You don't have to reduce the fractions if you don't want to, but I went ahead and did it. Plus 2/7 J, and then plus 6/7 K. And so when I apply my tension out here, I'm just going to draw it resolved in these components. I've got 6/7 in the negative x direction, so 6/7 TCB. And the positive y direction, so again that's this way. So from here, it's attached here, it's going to apply a pulling force. I'm going to have 2/7 TCB. And then going up, I've got 6/7 TCB in the positive z direction. Okay. That is one free body diagram. You can include dimensions here. I'm going to need this 12 foot. I'm also going to need this 4 foot. Okay. Sum of forces, those work much like we've done before. Add them up, they should be 0. So everything in the x direction, I've got AX here. I got AX. And I've got, in the negative x direction, I've got some tension, minus 6/7 TCB. By the way, if you want to pause and write out your equilibrium equations, that's really good practice. You should be able to go from a free body diagram to equilibrium equations. Sum of forces in the y direction equal to 0. AY is, I've drawn it positive, and I've also got positive y component of this tension, so plus 2/7 TCB. And then sum of forces in the z direction, sum of forces in the z direction equal to 0. I don't have anything here, but I do have 6/7, so positive 6/7 of that tension. So some of that tension is the positive z direction, 6/7 of it to be exact. And then in the negative z direction, I've got a force right here, minus 45 pounds. Okay. Now, I'm going to do sum of moments about each axis. You are welcome to do R cross Fs if that's your preference. Again, we talked about that is entirely up to you. I don't mind either way. Sum of moments about the x-axis for me are going to be 0. It should be the same for you. I'm going to add in my reaction moment here because it's a couple moment. So I don't forget those. I'm going to add my couple moments in first. I've got a reaction in the x direction, couple moments. And then also, let's look at forces causing a moment about this x-axis. Forces causing a moment about this x-axis. Well, this force, this 45 pounds, passes through the x-axis. There's no moment caused there. This y component passes through the x-axis, so no moment caused there. And also notice both these reactions pass through this, this is in the x direction, this passes through the x-axis, so there's no moment caused there. But, and then this is in the x direction, so there's no moment caused by any x direction forces. The only thing not passing through the x-axis and not in the x direction is this guy right here. This guy is trying to twist this thing about this x-axis here. So I've got 6/7 acting 4 feet away from this x-axis, put my thumb in that positive x direction, notice that this force is, the 6/7 is trying to close my right hand. When I put my thumb in that positive x direction, that kind of hurts to twist that way. So that is plus 6/7 TCB. Oh, you can't see that, I apologize. Plus 6/7 TCB acting at a distance of 4 feet. That's this guy. 4 foot away from this x-axis. And that appears to be it. Let's look at the next axis. Sum of moments about the y-axis. That is this guy up here. I'm sorry, I'm a little bit off screen. Sum of moments about the y-axis up here. That should add up to be 0. I've got a reaction moment. I do have a couple moment up there. Reaction moment, couple moment in the y-axis. All right, so what else is causing a y moment? Well, all these forces, this is in the y direction. This passes through this y-axis. This guy, this x component here, passes through that y-axis. This is in the y direction. This force, though, does not pass through the y-axis, and it is not in the y direction. So this guy, if I put my thumb in the positive y direction, that 45 pounds is out here trying to close my hand. If I apply it in that direction, it's trying to close my hand. So it's plus 45 pounds MRY plus the 45 pounds is 45 pounds. And that 45 pounds is acting at this long 12 foot away from this y-axis here. So there's 12 foot out there. And then also, I've got this guy. Also 12 foot away from this y-axis. Notice if this is causing a positive, this one's causing a negative. And if I put my thumb in that positive y direction, notice this 6/7 tension is trying to open my fingers. Right? It's trying to push up against my fingers in this direction. So that is actually a negative 6/7 TCB acting at a distance of 12 feet. Next page. Lecture 10. This is page 6 of something. Probably would be page 6 of 6 if I had to guess. I do need to find some moments in the z-axis. So let's cover these guys up. I can actually show this one here. Some moments about the z-axis. Again, if you want to do r cross f's, go for it. This video is going to go a little longer. I apologize. Some moments about the z-axis. I've got this reaction moment here, MRZ. So add or subtract all the couple moments. I've got MRZ there. These are passing through the z-axis, these forces here, so no moments caused by those. This force is in the z direction, so no moment caused there, and same with this guy. This force is in the z direction, so no moment caused there. I do have 2/7, right? And it is a distance of 12 feet away. Now what about the sign? Well, if I put my thumb, I can kind of do it like this. My thumb is in the positive z direction here, and those 2/7 are trying to cause my fingers to close. Right? Those 2/7 are trying to cause those fingers to close. That's a counterclockwise rotation about the z-axis. So plus 2/7 TCB, and again that is a distance of 12 feet from that z-axis. And then I've also got this guy. This is not in the z direction. It is not passing through the z-axis. It is 4 foot away from the z-axis. And it is also trying to cause a clockwise rotation about that z-axis. This is plus 6/7, or if I put my thumb in the right and thumb in the positive z direction. This one you can kind of see, right? So I've got my thumb in the positive z, and I try to push my fingers in the direction of this 6/7 force there. If I try to push my fingers in that direction, notice they close. That is a positive z force, or a positive z moment caused by a force that is 6/7 TCB, and it is again acting a distance of 4 foot away from that z-axis. So that is your equation there. So what do I have here? I have 6 equations, and 1, 2, 3, and it's the same TCB all throughout. It shows up in all the equations. Same TCB throughout. 4, 5, 6 unknowns. Notice this one. Well, I should say pause, do your algebra, and come back. That's what I'm going to do. I'm going to pause, I'm going to do the algebra, and come right back. All right. These are what I got. I did these real quick here. I may have made a mistake. I did not double or triple check these. If you're getting something different, right, either check the comments down below or write in the comments what you got, and we'll go from there. Okay. All right. That should let's finish lecture 10 there, and we'll pick up there with the next lecture next time.